Everyone, thank you so much for being here today. My name is Fernando Rocha. I'm a worldwide mobile specialist solution architect in AWS. And today I want to show you how I was able to build a full stack secure location-based application on AWS that has an event-driven backend. It has real-time capabilities and also geospatial capabilities like tracking and geofencing. All of that powered by AWS services like Amazon Location Service and AWS Amplify. So let's see how I structure the presentation today. The first thing we're going to see, we're going to do things a little bit differently here. The first thing that I want to show you is a demo. I really want to show you the functionality that the application has. So when we jump into the building blocks, and we're going to talk about the building blocks from a front end and back end perspective, it is easier for you to understand why we chose certain services. We're going to dive deeper into two services today. They're the main protagonists today. One of them is AWS Amplify, and the second one is Amazon Location Service. We're going to dive a little deeper into every single one of them. Then I'm going to show you how you get started, how you can get started building this particular solution by following a very comprehensive step-by-step guide. But how you can enhance this, how you can go beyond and build your own geospatial solutions on AWS. Then we're going to do a quick Q&A so you can ask me questions and I'll try to answer them. So let's start by jumping into the demo. Now our demo is going to be extremely simple. We have two main mobile applications here. On the left, you see one that I'm calling the Patrol app. Right, so imagine that you are an emergency patrol manager and you are responsible for managing the security of people during an emergency training. So let's say you sound an alarm and you have 1,000, 3,000 people going down the stairs and they all need to gather around a muster point. Right? When they get into that muster point, you need to know exactly who is there and who is not, because you need everybody to be there because they all need to understand the emergency procedures of your company. That can be really tough to achieve. Right? It doesn't really matter how many people you have involved in this process managing it. It is quite hard to make sure that everybody's safe in real time during an emergency situation. So the goal of this application here is to create a process where you can detect people and their position in real time and really know where they are, if they are in a safety area, a muster point, a safety space, whatever you want to call it, or not. So on the left side, we have the Patrol application, and that Patrol application has a list of all of the people, you can call it employees, students, whatever you want to call it, from a place where you are running this emergency exercise. And on the right side, you have what I'm calling the user application. And the user application has a very simple process. And the process around the user application is we have a map and we have polygons in red that represent safety areas or muster points. So when an emergency event occurs, those red polygons, they are painted on a map and the user knows where to go. Once the user starts moving, the patrol will know if they are currently in a safe place or not. And how do we do that? I have a process that fakes the movement of a user here. But the idea is, once the user starts moving on a map as this one is, it's going to start sending its information back to AWS. All the latitudes and longitudes that it is generating, they are being sent back to AWS in near real time. And the idea is, once the user crosses a geofence, or a muster point, whatever you want to call it in this particular case, this information is also being collected by AWS and evaluated against every single one of the muster points that we have created on Amazon Location Service. Now, after this geofencing event occurs and it realizes that the user is inside a geofence, Jeff, which is the user that is currently logged into this application, is marked as safe. Okay? Now, let's say that we want to move Jeff outside the geofence. Jeff is still sending its location back to AWS, latitude and longitude, and in a matter of seconds, we'll be able to see Jeff moving from a safe place, a safe category, a safe status, to an unsafe status. Now, Jeff is now unsafe. And that's how the process works. It's a very simple application, very easy to understand, but very powerful in a way that it can really help people in these emergency situations. Now, let's see how we put this all together. Let's talk about the building blocks from a front-end perspective and then from a back-end perspective. The mobile front-end, it has a few components associated to it. First, we need to talk about Swift. Swift is Apple's programming language of choice to build iOS mobile applications natively using Xcode. And we're also going to use Core Location, which is Apple's location-based library. We're going to be using that to track the user's current location. Then we're going to use AWS Amplify to provision the backend and also to connect our mobile front end to the provisioned backend via a very simple and opinionated library that AWS Amplify provides. The third piece of the mobile front end is the Amazon Location SDK. We're going to be using that to send the current location from the user to Amazon Location Service, and also to collect the geofences, those red polygons that you saw, that we're going to be creating in a few steps. Let's understand a little bit more what Amplify can do and what it's doing in this solution. So to build this particular solution, we have paired the Amazon Location Service with AWS Amplify. And Amplify is just a set of tools and services that can be used together or on their own to help you, a front-end web and mobile developer, to build any scalable full-stack application using AWS services. With Amplify, you can configure those backends and connect your application to them in minutes. I'll show you how to do that. You'll be able to deploy static web apps in a few clicks, and you can also manage your app content outside of the console. And Amplify supports a lot of popular frameworks like JavaScript, React, Angular, Vue, Next.js, and you can also use it for mobile applications like we're doing today. It supports Android, iOS, React Native, Ionic, Flutter. And the way that it works is you can deploy the backend of your application a couple of ways. You can use the CLI for that, which is what we're going to do in the next section here when I jump back into the code. Or you can use the admin UI. You can just go to a console, very user-friendly, start building your components, and then start developing on top of them. It also has a set of libraries and UI components that we're going to be using today to connect our front end to our backend built in AWS via AWS Amplify. And it has a lot of feature categories: authentication, data store, and APIs and functions are some of them that are going to be using today. You can also add storage, analytics, pub/sub, predictions, interactions, and notifications to your applications. All of these categories are powered by AWS services. For example, we're going to be using AWS AppSync to create our GraphQL API. And we're going to be using Amazon Cognito to create our authentication and authorization layer. And we also have Data Store to provide the real-time capabilities that our application needs via subscriptions, also powered by AWS AppSync. So let's jump back into the code and see how we can build this from scratch. Now, the first thing we're going to do here, the first thing you need to understand is that there are a few prerequisites you need to complete before you get to this stage. Okay, you need to clone the project. You also need to install and configure API, the AWS CLI, and everything that goes around that. But don't worry. If you want to do this particular project on your own, you can follow the step-by-step guide that I'm going to be providing the link at the end for you here. So don't worry about that. We're just going to jump ahead a little bit here for the sake of time. So the first thing we're going to do, since now we have our Xcode project cloned and we have all the Amplify libraries inside that project, we're going to initialize our Amplify project on AWS. So for that, we run amplify init. And we're going to be presented with a set of questions here. The first question that they ask is the name of the project. Let's call this project Safety Tracker. I'm going to configure this from scratch just so you see how it works. The next thing they ask is a name of the environment. I'm going to call this a development environment. If you are in QA or production or pre-prod, you can name your environment wherever you want. My default editor will be Xcode because this is an iOS project. The application that I'm building is an iOS application. And then it's creating an AWS CloudFormation template for me. And if you're not familiar with AWS CloudFormation, what it is you can think of it as our infrastructure as code service. Okay, what it does is it amplifies automatically generated infrastructure as code for us. That can be done either in JSON or YAML by you. And Amplify is going to use this template to build our backend infrastructure on AWS. For my authentication method, I'm going to use my AWS profile, and I'm going to use the default profile. So now this CloudFormation template is being created. They are creating this backend environment to AWS, and then I'm going to have a project deployed there. Now that the deployment has been completed, we have a couple of things we can do here, right? Now we're ready to start building our environment. We can start creating the components that we're going to be using in this application on authentication, APIs, functions, etc. But before that, what I want to do, I want to jump back into our presentation, and I want to talk to you about our next service, right? Our main protagonist of the night, if you will, which is Amazon Location Service. You can use Amazon Location Service. We're actually going to use Amazon Location Service in this particular project for two main reasons. One of them is tracking. We're going to pick up the geolocation that we're capturing from the user and sending it back to Amazon Location Service. And we're also creating geofencing capabilities using Amazon Location Service. What that means is that not only we're storing our geofences in the service, we're also generating geofencing events based on the tracking events that we're sending. For every latitude and longitude, Amazon Location Service compares that location to all the geofences you have stored, so you can detect if you are inside or outside a certain geofence, which is great. So it's a fully managed service. You don't need to spin up any infrastructure to start using it. AWS takes care of that for you. And it not only provides tracking and geofencing capabilities, it also provides capabilities like maps, routes, and places, which means you can search for points of interest and also do geocoding and reverse geocoding. And for these three features, it relies on high-quality geospatial data from two AWS partners who are very well established in the market, Esri and Here Technologies. Esri and Here will help you with these functionalities, which again are globally available. From a data privacy and security perspective, every query sent to Esri and Here are anonymized, so they will never know which account or person is making certain calls. AWS also has terms of services that prevent Amazon or our third-party partners to use your data for marketing or sell your data to other providers. So it is a service that really cares about your data privacy. There's also no vendor onboarding. You can choose to start using the service and stop using the service whenever you want. You can benefit from a free tier to start using the service for 3 months. And then again, it is a major part of our application because it allows us to build things that are somewhat different to do. It allows us to create an event-driven architecture. On every time we have a geofencing event, we send that information back to the application itself. You see how that works. Now, with that said, let's jump back into the console, to the coding part, and jump into the console so we can start using Amazon Location Service and creating our resources there. Now, the first resource we're going to be creating on Amazon Location is our geofence collection. And we're going to be calling this geofence collection safety zones. You can add a description to it if you want. Since we're just simulating data, I'm going to select yes here to use the request-based usage plan. I'm not going to configure Event Bridge automatically. Event Bridge is used in this case to collect geofencing events automatically and then sending them to other services that you can configure. We're going to do that in a few minutes, but I don't want to create a rule now. I want to create that later. Then I'm going to create my geofence collection. Now that my geofence collection is created, I can start adding geofences to it. And I'm going to use the console to do that. Now, if I'm going to do that via the console, I'm going to need to use a GeoJSON file. A GeoJSON file is a very popular format to create polygons that are related to geospatial data. You can use free services like geojson.io to build your own geofences, save them, and then load them into Amazon Location Service. I already have a GeoJSON file ready for us to use. Great. Now that I have my geofence collection created and the two geofences that I want to use, I'm going to jump into trackers, and I'm going to create a tracker. Now, what this tracker is going to do, it is going to receive all geolocation information from the devices that I have connected to it. Well, let's create a tracker here. Let's call it safety tracker. You can add a description if you want to. Same way, the same process we're going to do here. I'm going to choose this particular pricing plan because we're only using simulated data. And I'm going to create a tracker. Great. In this next step, I'm going to do something that is going to allow us to detect geofencing events automatically. When I link a tracker to a geofence collection, that's how I get the functionality where for every single geolocation that I provide to the service, this geolocation is going to be compared against all of the geofence collections that are associated to this tracker to create the events of enter and exit. So let's link it with the geofence that we have created in the previous step. Perfect. Now we have, at this point, created our Amplify project, and we have initialized our Amazon location resources. The next step we're going to do, we're going to configure our other resources that we're going to use in this project, but we're going to do most of them via Amplify now. So let's get back into the presentation for now so we can talk about the next steps. Well, let's start by configuring the authentication and authorization processes that we're going to be using, right? So for that, we're going to be leveraging Amazon Cognito. Again, another managed service by AWS that is going to be helping us with our authentication, which means creating users, creating user groups, and also authorization, allowing access to those users to our backend services created in AWS. Now, let's jump into the terminal and add that piece to our project. Now, to initialize Cognito, I need to do amplify, add auth. That's going to initialize the authentication category. In the same way that we had on, when we created the project, it's going to give me a list of questions. So for this particular one, I want to use default configuration with social provider because I want to use the web forms that Amplify gives to me, which is called hosted UI. There are a couple of ways you can do authentication process here from a UI perspective. You can build your own UI, you can build your own UI flow, but you can also benefit from the hosted UI, which is provided by Cognito, and it is what we're going to be using. So for that, I'm going to need the full configuration with social provider. I'm going to use username as an authentication method. And I don't want to configure any advanced settings. Let's create a domain. The domain can be named safety tracker, no problem. And then we need a redirect sign-in URI and a sign-out URI. So we're going to be using the same one in this particular case since we're talking about a mobile application. Let's call it my app. There's no other. And let's use my app for the sign-out URI as well. Now, I don't want to add any social provider to it, but if you want to, you can integrate this with Facebook, Google, Amazon, or Apple. Now, the CloudFormation template is being created for me. And after that, I'm going to be able to push this backend to AWS. All right, so everything was configured. Let's call amplify push. And amplify.push, what it's going to do, it's going to pick up this environment that was provisioned locally to me and send it to AWS. Great. Now we have a fully managed authentication and authorization resource created via Amplify using Amazon Cognito. The next piece we need to create is our API layer, the one that's going to send our information that is being collected on a mobile device back to AWS and stored in Amazon DynamoDB. So for that, we're going to create an API layer using AWS AppSync. AWS AppSync, it's AWS's managed GraphQL service. We're going to be using that not only as an API layer, but also for a subscription process, which is going to handle our real-time capability on the app. Every time we get a geofencing event on Amazon location, that event is going to be communicated back to the front-end application, to the front-end mobile application via a GraphQL subscription, which is going to be updated in real time. So we're also going to be using DynamoDB as our NoSQL database to hold the user data and its safety status. Let's configure that on Amplify right now. Now we're going to be creating our data store category, our API and data store category. And for that, I need to run amplify add API. Just like the other services, it's going to ask me a set of questions to know which type of API I want to create. I want to create a GraphQL API. We can call it safety tracker. And then this is an important piece. It's asking me what type of authorization I want to use. I'm going to use two types of authorization for this particular application. The first one I'm going to use is an Amazon Cognito user pool, and that's going to allow the communication from the mobile app to AWS AppSync. So let's start with that. I want to configure advanced settings. And I want to configure additional auth types. Another authorization type that I want to create is the IAM authorization type. And the reason why I want to do that, when you see the whole architecture is going to make more sense to you, but I want to create an IAM authorization because I'm going to need to connect a Lambda function back to AWS AppSync to allow the communication between the event-driven service we're going to use and AWS AppSync. It's gonna function as a bridge between the two services. You understand this a little bit better on the next step. I'm going to enable conflict detection because since I'm dealing with real-time capabilities, I may have multiple people sending information back and forth from the app to the backend service. You can have multiple conflict resolution strategies for this API. I'm going to use auto merge to facilitate. And I'm going to say that I don't have an annotated GraphQL schema. The way that AWS AppSync works and the way that Amplify Data Store works in this particular case, it's going to need an annotated GraphQL schema to define the type of entities we're going to be using in our application. So I'm going to say no for now. But I want to create a template. I'm going to create a template which is a single object with fields. I don't want to edit this schema at this moment. I'm going to do this later. Now let's take a look at the schema that we're going to be using to create our models, our entities on DynamoDB and AppSync. This is a very simple schema that we're going to be using. It is of type model, and the name of the schema is the name of the entity, the model itself is user. We have three attributes associated to this user. The first one is ID, which is a primary key. We have also username and a Boolean attribute called isSafe that is going to hold the safety status of the user, so we can paint it green or red. It also has the authorization rules that we created for user pools and IAM with the operations read and update for both of them. Now, Amplify also created a couple of files for us here, one called AWS configuration and another one called Amplify configuration. And these files are here just to hold the information associated to the resources that we are creating on AWS. So our front end knows with which resources it needs to communicate back when it goes back to AWS for online capability. So that's what all these files are doing here. Now, next step we're going to do here, we're going to run Amplify code gen models. And that it's going to generate all the models that we're going to use in our application, which now is just user, but it's going to generate the files associated to that. Okay, now that we have these models generated, we can come back here and we can take a look at the Amplify models that were generated for us based on our GraphQL schema. It generates an Amplify models file, a user schema file, which has the auth rules and other information, and also the most importantly, the user file, which is the model that we created with all the attributes that were selected by us, plus a couple that are associated to the data store functionalities, offline capabilities, and also real-time capabilities. So it already creates the constructors for us, and it is really, really helpful, right? Because you don't need to build this all manually, and it already associates back to AppSync and also to a table in DynamoDB. Now we can push this back into AWS, and then we can move forward to the next step of our solution. Now that we have deployed our data store category, let's take a look at some of the code that we're using to support authentication and connecting back to AWS AppSync to save our user. Let's take a look at auth service first. We have a couple of methods here that we're using to support the authentication process using the Amplify libraries. The first one that we're going to use here, we're calling this method check session status. And the check session status method, what it's doing is it is fetching the current authentication session that we have with this user, right? If they are logged in, if they're not logged in, and once you fetch that using the API amplify.auth.fetch auth status, we're going to save that in a global variable called isSignedIn. And that's going to help us manage our authentication process. The next method that is good for us to take a look at, it's called signing with web UI, okay? And that basically kicks off the signing process. By using amplify.auth.signing with a web UI, what we're doing here, we're opening the host web UI, which is the one that you saw, where we were able to sign in with the user Jeff, and then handle the whole, not only authentication, but also creating a new user, right? And handling multi-factor authentication, handling adding a code to validate a sign-up process. Everything's handled using the signing with web UI. So it's just an easier way to handle a whole sign-in, sign-up, sign-in flow and validation flow from a user. We have a method called manage user, which is basically getting the current user from Amplify. So by calling amplify.auth.getCurrentUser, we're going to get the user that is currently logged in. After that, we're going to move into another category, which is amplified data store. And what amplified data store.query is doing in this particular case, it is verifying if this user that it is logged in, if it exists in the database. If it doesn't, it's going to create a new user for us using the authenticated user ID. And then we're calling a method called save user to create this user entity, and using amplified data store.save to save that user back in DynamoDB for us. And that's basically the sign-in process. Now, we have the sign out process here, and the sign out process, it is pretty simple. What it is doing is it's calling amplify.auth.signout, and that's going to sign out the user. A good practice after that, since we're using Amplify Data Store, and that comes with offline and real-time capabilities, it's calling amplify.datastore.clear. And that's going to clear out all of the data that you have stored on your device using Data Store on your application that is not yet synchronized back to AWS. So that's just a good practice to do when you're handling, when you're using Amplify Data Store's offline and real-time capabilities. Now, let's go back to our presentation so we see what the next step is in our process to build a solution. Now, as I mentioned before, we're going to need a supporting function, which is going to be an AWS Lambda function, who's going to be responsible for communicating the piece that the event-driven model is supposed to do. So whenever we get a safety status change from safe to unsafe and vice versa, and that is generated by Amazon Location Service on a geofencing event that is sent to Amazon Event Bridge, we're going to need a supporting function to communicate that information back to AWS AppSync. So AppSync knows that it needs to run a mutation, so it communicates this information back to our NoSQL database and also to the front-end application that is listening to it. So how do we create a Lambda function using AWS Amplify? Going back to our terminal, we're going to run, let me clear the terminal. We're going to run amplify add function. And the type of function we're going to be creating is a Lambda function, serverless function. Let's call it safety tracker function. It's going to be an Node.js function. We're going to use a template hello world. And I do want to configure advanced settings. And the reason why I want to do that is because I want to allow my Lambda function to access other resources in this solution. I want you to access my API because it's going to communicate the information back to my API, if you remember correctly. I want to allow it to do queries and mutations. I do not want to invoke this function on a recurring schedule, and now we can just say no to everything. And then we can take a look at the Lambda function that we're going to be creating. So there are a lot of information going on here, but mainly related to the authorization part of how the Lambda function is going to communicate back to AppSync. But the important piece that I want to show you here is the mutation that we're going to be creating, which is a mutation that's going to update a user, passing all the information associated to it. The ID, if the flag, if it's safe or not, a username, created at, updated at, the last change at, a version, and if it is deleted or not. And we need to pass all this information so AppSync knows that it has a mutation happening and it can communicate back to all the front ends who are subscribing to it. Now, with that, we can take a look at query user. And query user is going to do a very simple thing. Before we mutate the user, we just want to get the user that is generating that change. Which user do we need to modify at this point with a safe or unsafe flag? After that, we just send the information back to AppSync, grab the return, and then we're ready to move forward. Once we're done deploying our function, let's take a look at the other services we're going to need to use. So we already know that we're using Amazon Cognito for authentication and authorization process. We are using AWS AppSync for our API layer and subscriptions. We're using DynamoDB as a NoSQL database. We have AWS Lambda as a supporting function, and we're using Amazon Location Service for our location-based data and activities like tracking users and also generating the geofencing events. Now, what is Amazon Event Bridge doing? Amazon Event Bridge is a service which is going to help us with this portion of our event-driven architecture. Its purpose is to collect the geofencing events that are happening at Amazon Location Service and sending that event as is to AWS Lambda. So AWS Lambda can continue the process with AppSync, DynamoDB, and the front-end services. Now, let's see how this works. Let's move back to our console. And let's create a new rule on Amazon Event Bridge. Let's call this rule safety rule. This rule is going to come from an event pattern, predefined from an AWS service. That AWS service is, of course, Amazon Location Service. And now the event type that we can choose is a location geofence event. And if I want, I can even specify the types here. If I want enter or exit events. Since I want to check if my user is safe or unsafe, I want to do any type. After that, I need to select a target. And the target that I've created is our safety tracker function dev. So once a geofencing event happened, I want my safety tracker function to be triggered automatically. Now let's create this. Perfect. Now my rule has been created. And that was the last piece of infrastructure that we need to create here. All of my resources are now created. The only thing that is left to do is for us to take a look at the architecture as a whole, so we can understand the process properly. And then I'm going to show a little bit more coding to you, but let's start with the architecture. Now let's put everything together. And on the right side there, you have a QR code that's going to take you to the solution. And that's going to help you build a solution on your own. It has a very comprehensive step-by-step guides with prerequisites, how you can run the application, how you can install Amplify and install the CLI. Everything's there for you. So let's put it all together. We have two main mobile applications. We have the user application that is leveraging AWS Amplify and Amazon Location Service to communicate back to the AWS cloud. We also have the patrol application that has a list of users that are safe or not, marked in red and green. And it's also leveraging AWS Amplify to connect back to the AWS cloud backend. On the AWS cloud, we have Amazon Cognito for authentication and authorization purposes. The user application connects to AWS AppSync to store the user information once it is created. That information is sent back to Amazon DynamoDB, which is our data store at this moment. The user application uses the Amazon Location SDK to communicate the user's information back to the tracker and also to collect the geofences. This tracker information is evaluated against every single geofence we have on our geofence collection. And once we have an enter or exit event, that information is sent directly to Amazon Event Bridge. Amazon Event Bridge picks up that information, understands that it is a geofencing event, and that it needs to send that back to our AWS Lambda function. Our AWS Lambda function has its sole purpose to communicate that information back to AWS AppSync, which is going to save that information on DynamoDB. And also via subscription mode, it's going to update the patrol app, deeming the user safe or unsafe. So this is how it all ties back together. It is a very simple architecture that is doing a lot of things. Now, the last piece that I want to show you, let's go back to our code here, to Xcode. So we can take a look at what the code that collects the geofence looks like. I want to show you the code that also tracks the user and also the subscriptions. Let's start with the code that gets the geofences. If you go to geofence handler, you see that we're calling a method here called list geofences. And we're creating an AWS location list geofence request using the location SDK. We set the collection name as a geofence collection name that we set on our bundle. And then we call AWS location.default.list geofences, and we get all the geofences. After that, we're going to create the polygons that are going to be used to paint. We're calling them overlays. We're going to be creating the overlays to paint the map that is going to provide those red polygons that you were able to see on the demo. Now, if you go to location manager.swift, we're going to be able to see how we're tracking the user's location here. So first of all, we run that basic process where you need to ask for permission to track a user. In this case, we're doing it when the app is in use. We're not tracking it in any other case, only when the app is used. Once the authorization changes, when the user says, yes, you can track me, we're going to use the location tracker and call start tracking. In this start tracking method, we have a few things that we're adding here. The first one is we're sending the device ID, we're setting the device ID that we're going to use on this tracker to the current user authenticated user ID. So the user ID that Cognito is generating to our user is the user ID that's going to identify the device related to the tracker. So once we have a geofencing event, I know exactly which user I'm talking about. I'm also saying that I want to retrieve the location frequency every 5 seconds, and I want to send this location back to Amazon location service every 5 seconds as well. If the user, if the user stops using the app or he moves away from the tracker, we're calling location tracker.stop tracking just as a method of security. There's also a listener. Every time that Apple's core location library collects new locations, we're calling intercept locations retrieved, so we can do whatever we want with the locations and then send them back to Amazon location service. The last piece that I want to talk about are the subscriptions. And the subscription is going to be on our muster point patrol application here inside our content view. So we have two methods going on here. The first one is query users. And the query users method is just running a method that you already know how to use, which is amplify.datastore.query. And that's picking up every single user that we have on our database on DynamoDB. And that's really important. But the real hero here is the subscription piece. If we call amplify.datastore.publisher, what we're doing here, we're creating a subscription, meaning that every time it detects a mutation that happens on AppSync, this is going to update my interface automatically. And the way that I'm doing this currently, I'm just running query users again. You can have some deeper granularity when you do this, because once you receive a mutation back from AppSync, you really collect every single piece of change that happened. So if you want to change just the small pieces on your UI, you don't need to query all of your users again. You can just pick up the exact information that was changed. Perfect. Now let's recap what we've done here today. We're able to leverage AWS services like Amazon Location Service and AWS Amplify to build a solution that has real-time capabilities using an event-driven architecture to detect if a user, an employee, a child, whoever you want to track is safe or not during an emergency situation. Of course, this use case can fit many other use cases, right? We can talk about geo-marketing, asset tracking, asset management. It doesn't really matter. But overall, we were able to accomplish this by using Amazon Location Services, tracking and geofencing capabilities, pairing it up with AWS Amplify, who was able to provision this backend for us that fits very well with an event-driven architecture that's also powered by Amazon Event Bridge. You can deploy this particular solution by following the QR code on the right, or by going to the solution guide on GitHub. Okay, you can also go to our Amazon Location Service developer guide so you can understand how to build a similar application, move beyond that, or create applications that leverage the other features provided by Amazon Location Service like maps, routes, and places. We also have a GitHub that has samples only related to Amazon Location. You find a lot of cool projects there for you to follow. And a very nice feature that just came out from the Amplify team. Amplify Geo is in preview for JavaScript now. It now allows you to add mapping and search for places of interest capabilities to your web application in an easier way. Great. So with that said, I need to thank you all. It was really great coming here today and talking to you about this. I'm really passionate about mobile applications. I'm really passionate about geospatial capabilities. So it was great. Thank you so much. And I'll see you next time.